Good morning, kiddos. Today we're going to be going through dilations on a coordinate plane. As always, feel free to pause and rewind on your own pace. All right, so remember, a dilation is a type of transformation that enlarges or reduces a figure, but the shape stays the same. The dilation is described by a scale factor and center of dilation. So for scale factor, the scale factor, which is going to be represented by the letter K, is the ratio of the length of any side in the image to the length of its corresponding side in the pre-image. It describes how much the figure is enlarged or reduced. So this is the formula we're going to be using. Basically, to be your new side over your old side. And most likely you'll see it as pre-image over image. Okay, so your pre-image is going to be you'll see it as image over pre-image. I'm so sorry. Your pre-image is going to be your old one, and your image will be your new one. Again, your pre-image will be your old side, your old shape, and your image will be your new one, okay? So it says the dilation is a reduction if scale factor, which is this K, is less than 1, and it's called an enlargement if your scale factor, which is this K again, is greater than 1. So if you find your scale factor and the number is less than 1, you automatically know it's going to be a reduction, meaning your shape is going to go from big to small, okay? And if your scale factor is greater than 1, it's going to be an enlargement, meaning your image is going to go from small to big, okay? So let's look at what we have here. We have PQR is congruent to PQR, well, P apostrophe Q apostrophe R. And so if I look over here, see all of that right there? And look over here, right? So we're going to just use side PQ, which is going to be for my new image. Well, P apostrophe and Q apostrophe, which is for my new image. Let me go back, sorry. Over PQ, which is our old image. And they're equal to the scale factor of the dilation, okay? Let's clear that up for you. I know that was a bit confusing looking at it like that. So, because the size enlarges or reduces in a dilation, it does not preserve or keep congruence the same size. Because I do not change the direction of a figure when I dilate it, the orientation stays the same. So no, it does not preserve congruence, but yes, the orientation does stay the same. So let's look at this example. To determine if A, B, C, D, and A apostrophe, B apostrophe, C apostrophe, D apostrophe. So when you see these apostrophes, you know that this is going to be your new image and this is your old image, all right? Are similar figures. If so, identify the scale factor of the dilation that maps A, B, C, D onto A apostrophe, B apostrophe, C apostrophe, D apostrophe, as well as the center of dilation. Okay, so first of all, we can look at this and tell if this is a reduction or an enlargement. This is our original image and this is our new image. So what do you think it is? If you said it's a reduction, you are absolutely correct, right? So what I would do is I would grab any side, but it has to be a corresponding. So remember we say new over old, and this is our new shape right here, and this is our old shape. So I'm going to just take C to D, and I'm going to use this 4, and that corresponding number with this 4 will be 12. So the new is 4, the old is 12. If I did 4 over 12, I get 1/3, which is less than 1. So again, that proves the statement that if it's less than 1, it's a reduction. So what now? We will use the knowledge we have of similar figures and apply it to similar figures on a coordinate plane. As a 7th grade GT student, we must be able to find the scale factor between a figure and its dilation on a coordinate plane. So to find scale factor, select the corresponding x value or y value and use the formula for scale factor, which is image over pre-image or new over old or new over original. All right, so I'm going to stop here because the video is going to stop me, and then I'll come back with part 2 and we'll start up right here, okay?